Hi everyone, we are on this topic of ultrasonic testing, and in the last class we have discussed a very important aspect of this particular technique, which is calibrating the instrument, because as I said, when the indications are indirect, you need to calibrate the instrument so that you do not end up with erroneous results, or whatever observations you make, those are correct. Okay, so in order to ensure that, you need to calibrate the instrument, and for this particular technique we saw in the last class that the two main things that you need to calibrate for a normal probe are distance amplitude calibration and area amplitude calibration. Okay, so these are the two things that we saw in the last class, but in certain cases, as I would have said before also, you need to use an angle probe also. So far whatever we have discussed for the calibration, it was for a normal probe, and in today's class now we are going to see how to calibrate an angle probe. Okay. So in order to do that, you need to use different type of block, okay, and this block is quite versatile in the sense it can not only do calibration for the angle, but it can also calibrate normal probes as well. Okay, and there are few more things that you can do using this particular block, as we are going to discuss today. Okay, so this block is known as IIW block. And this IIW stands for International Institute of Welding. So this block is specified by them, this institute. Okay. So if you see the block, it looks something like this. Okay, so let us say you have this kind of angle probes, this you have seen before also, and you need to calibrate it for the angle and few more things, as we are going to see. And for that, this is the IIW block which is used. Okay, so this is the block. Let me magnify a bit so that you can see it clearly. Okay. So this is how it looks like. Okay. So it is a block made of steel, and there are few features on this block, and with the help of these features we can calibrate an ultrasonic transducer and the instrument. Okay. If you look at the dimensions, these dimensions are something in this range. The typical dimensions, if you see, this length is 200, and you have a notch over here, as you could see, which is 2 mm. So all these dimensions I am writing in terms of millimeter. This radius is 100 mm, and the height is also 100. There is a hole over here, as you could see, in this particular location. Okay. So it is a small hole, the diameter of which is 1.5 millimeter, and it is at a distance of 15 mm from the top. Okay. And you have a bigger hole over here. Okay. So, this is a 50 mm diameter hole, and from this end it is 5 and from the other side it is 10 mm. Okay. And the total length of this whole thing is around 300 mm. Okay. So, these are the typical dimensions of this particular block, and now you could see there are several features on this. The first one you can see there is a curvature over here, this 100 mm radius curvature. Then as I said, there are two holes, one over here which is 1.5 millimeter, okay, and then the other one a bigger hole which is a through hole. This is 50 mm in diameter. Okay. So, let us see how this can be used to calibrate angle probes. Okay. So, this is an angle probe which is shown over here. You have seen it before also, and you have seen this plastic wedge has been cut over here to provide that particular angle that you need. Okay. So, the first thing that you need to know for this kind of angle probes is from this surface where exactly the beam is exiting. So, which exactly is the beam exit point, okay? Because the angle has to be calculated with respect to that particular point. Okay. So, there is a surface here and you do not really know as to what exactly is the exit point. So, first thing that you need to do, you need to find out that exit point. Okay. Then only you can talk about the angle, because as I said, the angle is measured with respect to the index point. Okay. So, this is the beam exit point is also known as the index point, and that is the first thing that you need to find out. Okay. So, in order to find the index point, you have to keep the probe on this surface somewhere here, and hit this curvature and get an echo from there. Okay. So, this echo from this curvature will be maximum when the probe is exactly on the center of this curvature. So, when the beam exit point is at the center of this curvature, you get a maximum signal. So, what do? You take this probe and then move it on either side like this till you get a maximum signal. Okay. So, the moment you get the maximum signal, you stop there and you mark that point. So, there could be a marking on the block also, which is the center of this 100 mm radius. So, that you mark on the probe as the index point or the beam exit point, right. So, in some of the probes you can already see that this index point is being marked, okay, right on the probe. Okay. So, if that is there, that will be your index point, and you can match it by this particular method, and if it is not there, then you should mark it like how I said, okay, getting a maximum signal from the 100 mm radius, and then at that particular point you mark the index point on the transducer probe. Okay. So, that is the first thing you do, and then you go on to calibrate the angle and other things. Okay. So, let us see how you calibrate the angle using this particular probe. Okay. So, in order to calibrate the angle, if you look here on this part, there is a scale graduated on this, on the block. Okay. So, that is the scale for the angles. You can see there are several angles which are marked there, like 45 degree and 60 degree and so on. Okay. Similarly, on the other side also, on the bottom also you could see, here also you could see along this area, here also you could see there are some angles which are graduated, which are marked on this surface. Okay. So, using these angle scales, you would be able to see what exactly is the angle of the ultrasonic beam which is coming out from an angle probe. Okay. So, in order to do that, what you can do, you can keep the probe over here on this place, okay, and then get an echo from this 50 mm diameter hole. Okay. So, what you do, you move this probe on either side like this again, so let us find out the beam angle from this. Yeah, so you, as I said, you keep the probe on this surface, and get an echo from this 50 mm diameter hole. Okay. And what you do, you move the probe on either side like this and get a maximum signal from the 50 mm diameter hole. So, when you get the maximum signal, you stop it at that point and then see from this scale that the index point of this probe is matching with what angle. Okay. So, that will be the beam angle. Okay. So, this is how you find out the beam angle first. Okay. So, this top surface that you have, if you keep it over here, this can be used for angles in the range of 45 to 60 degree, and for higher angles you could keep the probe over here on this surface. Okay. So, this will be 60 to 70 degree, because if you have seen the angles, the higher angles are on the lower side and on the top side this is the range. Okay. So, this is how you first get to know the angle. Okay. Once you have established the index point, you get the beam angle. But a beam angle will also have a spread, beam spread. Okay. So, this spread also you need to find out as to how much in the spread in the angle. So, what you do, once you establish this angle and the corresponding point for the maximum signal, you move this probe again on both the sides from that point of maximum signal. So, first you move, for example, towards the left till the signal becomes 0. So, move it on either side till the echo becomes 0. Okay. So, first you move it on the left hand side and then see at what point it is becoming 0. So, note down the angle when it is 0, and the difference of these two angles on either sides will give you the beam spread. Okay. So, first move to left and then see at what point it is becoming 0, note down that angle and then you go to the other side till the time it again becomes 0. So, note that angle also, take a difference of these two angles and that will give you the beam spread. Okay. So, this is how you find out the beam angle and the beam spread by using this IIW block. Okay. Then there are few other things as I told in the beginning that you can do by using this block apart from finding the beam angle. So, let us see what are the other useful things that we can do by using this particular block. One very important aspect, as we have discussed before also, particularly for closed surface analysis by ultrasonic testing, is the dead zone. So, you should have some idea about the dead zone for a particular transducer which is used for closed surface kind of analysis. That again can be found from this block, and again you can use this 50 mm diameter hole. So, what you do, you keep the probe at this point first and you know this particular distance is 5 mm, right. So, from this location, if you get a clear signal from the 50 mm diameter hole, okay, then it will indicate that the dead zone is within 5 mm or less than 5 mm, because you are getting a signal from a 5 mm distance by utilizing that particular probe. So, that will indicate that the dead zone is less than 5 mm. Okay. If you do not get a clear signal from this side, then you can put the probe over here, and you know in this case this particular distance is 10 mm. So, if you get a signal from 10 mm distance, but not from 5 mm, then that will indicate that the dead zone is between 5 mm and 10 mm. Okay. On the other hand, if you do not get any signal from this 10 mm distance also, then it will indicate that the dead zone is more than 10 mm. Okay. So, this is how you can get an idea about the dead zone also from this IIW block. Okay. I should also tell you at this point this dead zone, some idea about the dead zone can be obtained from the display as well. From the initial pulse that you have. Okay. So, the initial pulse, let us say if it might look like this. Okay. So, the width of this initial pulse will give you an idea of the extent of the dead zone for that particular probe, using which you have obtained this initial pulse. Okay. because within this particular distance you do not see anything apart from the initial pulse, you do not see any other echo, right. So, that means within this distance the probe is not receiving any echo at all, it is not able to receive any echo within this distance, and that is why that particular distance or the width of this initial pulse will indicate the size of the dead zone for that particular probe. Okay. We will see one more important aspect, one more important thing which can be found again by this IIW block, which is the resolution of any ultrasonic probe. Okay. Resolution means if you have two closely spaced defect lying very close to each other, then you should be able to get two different echoes from these closely spaced defects, instead of getting a single peak or two peaks merged together into one. Okay. So, if you get two separate echoes from these two defects which are lying very close to each other, then you say that the resolution of that particular probe is good. On the other hand, if you do not get two separate echoes from these two defects, then you say that the resolution is not good. Okay. So, with the help of this particular notch that you have over here, okay, you would be able to find out whether the resolution for that particular probe is good or not. Okay. And this we know it is a 2 mm wide notch. So, what you do, you place the probe on this surface. Let me use this. Okay. So, what you do, you place the probe over here on this surface, and then get echoes from this notch from 3 different points. Like first you get an echo from this, and then right from the root of the notch like this, and then again from the other side of the notch. Okay. So, let us call these points as x, y and z. So, you can see these points are very closely lying to each other within 2 mm. Okay. So, if the resolution of the probe is good, then you should be able to see 3 different echoes with respect to these 3 points like this, okay, y, x and z. And if your if the resolution is not good, then you will see that you are not getting 3 different echoes from these 3 different points. Okay. So, this is how this IIW block is also useful for finding other important parameters like the resolution, and also you would be able to get some idea about the sensitivity and things like that. Okay. So, this was about calibrating angle probes by using this IIW block. Since we have been talking about calibration in last few classes, so it will be good to summarize this particular process of calibration. So, let us do that. Before we close today. So, in case of normal probes, we saw that you can calibrate the distance and the area, and in this case a cylindrical block was used and this block had a flat bottom hole at the bottom of the cylinder and a particular metal distance. So, in case of distance calibration, the metal distance was varied, and in case of area calibration, the area of the hole was varied. Okay. So, that is how you get different distances in one case when you vary the metal distance to calibrate the distance, and in the case of area calibration you vary the size or the area of the hole, and that is how you get different areas to calibrate in terms of area. So, that was about calibrating normal probes, and when you have angle probes, there we saw that you could use a block which is known as IIW block, and in this block we have several types of features which can be used to calibrate the angle for a particular angular transducer. And on the block we also had this angle scale graduated, and with the help of that we could calibrate the angle. Okay. And apart from this, we also saw that this IIW block is quite versatile, in the sense that apart from calibrating the instrument or the probe for the angle, it can also do certain other things. For example, it is very useful for getting an idea about the resolution of a particular probe. Okay. So, that also can be done using this particular block, and then we also saw that you can also get an idea about the dead zone by using the 50 mm diameter hole that you had in this block. So, this is another thing that can be determined from IIW block, and that is why, as I said, this is a very versatile reference block which can be used not only for calibrating the distance or the angle, but it can also be used for getting these important parameters like the resolution, dead zone, and in fact you would also be able to get some idea about sensitivity. Okay. So, these are the different things that can be done with the help of the IIW block. Okay. So, finally, what we have for calibration, we did distance amplitude calibration, which is also known as distance amplitude correction or DAC. We did area amplitude calibration, this too with the help of cylindrical reference blocks. And for calibrating the angle and getting to know about resolution, dead zone, and sensitivity, this IIW block can be used. Okay. So, this is how the whole process of calibration is done, in order to ensure that before you do the test, the instrument and the probe is calibrated and you do not end up with any erroneous results. Okay, right. So, this is all I will have for today, and in the next class we will see couple of more important aspects for this particular technique. So, I am going to stop here today and I will see you next time. Thank you.